ही हूँ मैं, इसीलिए ही कॉल किया था, मुझे लगा तो आ नहीं रही। हाँ,
Hello everyone.
हाँ, आ जा।
So today we are going to solve. We'll
अरे
see
आ
the
जा।
we are going to see the week 8 assignment problems, practice questions. First we'll discuss the theory of the week 8, which mainly includes the advanced machining process, and then we'll solve the problems. Okay. So we'll wait for 5 minutes, then I'll start. Okay, we'll start now. So this is the last week we are meeting and we are discussing the various theories behind the week 8 contents, which includes the advanced machining process. We will see different kinds of advanced machining process in this lecture, and at last we will do the practice question for the same. Okay, we'll begin. So before starting the advanced machining process, I just want to tell you कि why we have conventional process, right? Like mechanical process, like conventional mechanical process like drilling, milling, turning, and many others. So why there was a need to shift from the this conventional process to the advanced machining process or non-conventional machining process, right? So basically what happens in case of conventional process, there is a contact between the tip of the tool and the workpiece. Basically there is a contact. So because of that contact, there comes various limitations, like it affected the workpiece finish. It can like it affected the tool properties, tool geometry, tool dimension, even like tool wear. It led to high tool wear. So this all the problems which originated in case of conventional machining. Therefore, to reduce this type of issues, like there was advancement in the machining process, which is called advanced machining process or non-conventional machining process. Okay. So in non-conventional machining process, what happens? The contact between the tool and workpiece is not there. There is no contact between tool and workpiece, and by the means of other medium, the medium can be a a fluid medium, so a liquid medium, a gas medium, any other medium, by using the voltage, current, by evaporation, blasting, and many different other processes. This materials is removed. This machining is done. This is the basics of the advanced machining process or non-conventional process. Okay. So we'll see what are the various classification of advanced machining process. As I already told, in mechanical process there is a physical contact between the workpiece and another material, but here in advanced machining process there is not a physical contact. So that is the thing which we have discussed. Now we'll see different types of mechanical process in advanced machining process. First is the ultrasonic machining, one is abrasive jet machining, one is the water jet machining, another is abrasive flow machining, and next is the magneto-heliological machining. These are the non-conventional machining which uses mechanical process for the material removal. Okay. Similarly, there are other non-conventional machining which uses other processes, like in chemical process, chemical reaction take place on the surface of the workpiece so that the material can be removed. In electrochemical machining, it is governed by the Faraday's law, in which one anode is there, one cathode is there, one concentration dilution is there, and there is a movement of charge. Because of that movement of charge, this MRR takes place. One is thermal based machining, which removes material by use of melting and vaporization. One is ion beam machining, in which the material is removed by the sputtering of workpiece because of the bombardment of the focused ion. An ion beam is focused on the workpiece, and because of when the ion beam gets strike to the workpiece, there is a bombardment of the focused ion, and because of that material get removed. This is the basic classification of the advanced machining process. Okay. Now we will go into detail of each and every processes. What are the various process parameters used in these processes, and other various the construction, the mechanism, the procedure, the methodology, everything we'll go and see. Okay. Now moving on. First we will talk about the mechanical non-conventional process, in which the material is removed without contact between a tool and workpiece, but the process is mechanical. It follows a mechanical behavior or process in order to remove the material. First is the ultrasonic machining. First is USM, which is also called USM. So what happened in USM? You can see, as you can see from the diagram. One second. Okay, so basically we have a workpiece. You can see here we have a workpiece, fine, and that above workpiece some slurry particles are there. Slurry is some kind of a liquid medium, okay, thick liquid medium, and this slurry is there, and on that slurry in that slurry some abrasive particles are there. In slurry only some abrasive particles are there. Slurry is basically made up of that abrasive particle only. Or basically you can say, okay, don't see this. Only slurry is present. Okay, in workpiece only slurry is present. So what happens? This USM works on the basis of, on the principle of this plastic deformation. Which leads to ultimately breakage. Okay, so what happens? This is a transducer. Transducer is used for the movement of the tool. One second. Just wait for 1 second. Okay. So what happens? This transducer is responsible for the movement of the reciprocating movement of the tool. This is the tool. You can see there. This is the tool, which is continuously moving up and down. Right? So what happens? tool moves up and down on the workpiece on this slurry. So this tool presses the slurry, this is a thick slurry, to the workpiece. So because of that, the slurry has an impact force. Basically, it is governed by some impact force. Impact force. Okay. So when tool strikes the slurry, push the workpiece with some impact force. Because of that, the particle, or the particle of the workpiece start plastically deforming. And ultimately, when we increase see what does this transducer do? This transducer provide a frequency for the tool movement. So if we increase the frequency, then the tool movement will increase, the speed will increase for the movement of the tool. And when the speed will increase, the tool will hit the slurry faster, and the slurry will hit the workpiece faster. So the plastic deformation will happen on a higher rate, leading to the faster breakage of the material, and hence you can see some of the material get braked and the machining is done. This is basically the concept of the ultrasonic machining. This is the basically concept. Okay, now we will see various process parameters and various points, because this is a very theory subject. You need to remember the points for the exam point of view. Okay, so we will see each and every point. First, in USM process, the abrasive 15 to 150 microns are driven at the high velocity against the workpiece. These abrasives are contained in the slurry. Okay, as I told, these abrasives are contained in the slurry. So one point to note is that the size of abrasive is around 15 to 150 micron. Depending upon the rate of removal or amount of removal, we use the size. If we require very high, removal, then more abrasive. Like that, depending upon the application, we use the size of abrasive. This question can be asked, or it can be used. Key size of abrasive 15 to 150 microns. Okay. The tool oscillates at very high frequency, because you want the breakage of the workpiece, right? You want the breakage, the material to get chipped off. So because of that, the transducer provide a frequency which is in the range of 19 to 25 kilohertz. And the amplitude, what is the amplitude? It is the maximum distance up to which the tool moves, this motion. What is the amplitude? Is 15 to 50 microns. Fine. Size is 15 to 150 micron. Frequency provided by transducer is 19 to 25 kilohertz, and the amplitude is 15 to 50 micron. Okay, fine. See next point. The tool oscillates perpendicular to the surface of the machine and throw particle of different sizes on the workpiece. You can see tool is this in this direction, workpiece in this direction. The tool is perpendicular to the workpiece, and after the machining happens, this particle get removed. These particles. Okay. The abrasive particles are suspended in a medium such as water, thus making a slurry. So basically, this slurry is a mixture of water, thick and other some liquid particle, and this abrasives. Okay. And it can ask which type of abrasives are used. So basically, abrasives used are boron nitride, aluminum oxide, silicon carbide, and boron carbide. These are very common abrasives which are used everywhere. Okay. Now, how does this process work? Okay. So this process requires basically electrical energy, because when you are providing, how transducer is working, it is using the electrical energy to provide this electrical energy is converted into the mechanical energy. See, this electrical energy, because of transducer, it converts into mechanical energy because of that tool moves. This process requires electrical energy. First, the low frequency electrical supply is transferred to a high frequency signal using an ultrasonic wave generator. There is an ultrasonic wave generator, something in the system, which transfer the low frequency electrical signal to the high frequency signal for the better movement of the tool. Okay. Then what happens? The high frequency electrical signal is converted into high frequency linear mechanical motion. So this electrical signal had to be given to tool for the movement, and tool is moving linearly, but it has to be converted into mechanical, because tool does not understand the electrical signal. Therefore, this electrical signal is converted into mechanical signal through which the tool moves. Okay. The motion is transferred to the tool through a tool holder, often called hone. It is not required. It is made up of monel, titanium, stainless steel. This is talking about the tool material. And in piezoelectric transducer, what happened when the current passed through the piezoelectric crystal, such as quartz and this, okay, it is saying when the current is passed through the piezoelectric crystal, the length changes because of the change, the strain is produced and it converted into an. This is a very simple thing. The principle used to convert electrical energy to mechanical energy with the conversion. This is very important. This point is very important. Ki when you are converting the electrical signal into mechanical signal, the whatever principle is used here. So the every signal, every complete signal, there is not a complete transformation of signal, right, from one point to another, from one source to another. So when it is converting from the electrical to mechanical, then there will be some losses, right? So that loss is only 5%, 90% conversion is happening. Okay, this is all about the ultrasonic machining. We will see a small video how ultrasonic machining is being done. 1 second. 1 second. One second. Just wait for a second. Please see the video. This is a slurry which is going on, and downside is the workpiece, and see upside is the tool which is continuously oscillating on the slurry, so that you can see this abrasive particles are going. See, abrasive particles lowering, and it is continuously hitting that abrasive particle on the workpiece, so that it may lead to the fracture of the workpiece. And you can see machining is being done. This is how ultrasonic machining is done. See, very precise and very good machining. Okay, now you have seen the video, and now we'll see next process, which is the abrasive jet machining. So what happened in abrasive jet machining? There in the slurry only the abrasive were present, and when you are hitting the tool on the slurry, so that the abrasive get touched into the workpiece. Now you are applying the abrasive through a nozzle, through a proper flow system to a workpiece. You are hitting the workpiece with not a tool but with a high velocity abrasive. So that, see, abrasives are very sharp in nature. So when you will hit the abrasive to the tool with a very high velocity, then what happens? Then it will lead to the machining of the tool, or the MRR. There will be a high MRR. This is basically a process. So proper flow system is there, gas is used, because you need to apply the abrasives into a very high velocity, very high velocity. So for that, proper gas supply is used, proper filters are used, valves are used, nozzle is used, and then it is applied on the workpiece. So we'll see what happens. In AJM process, the material removal takes place due to the hitting of the workpiece with a jet of gas containing the abrasive particle. As I already told, to move the abrasive very fast on a very high speed to the workpiece, it has to be concentrated with the gas, right? Because high speed of gas will lead to the high speed of abrasives. So it has to be mixed with some gases. So gas used are dry air, nitrogen, carbon dioxide, or helium. Okay. Typical parameters for this AJM process are: pressure generally used is from 0.2 to 5 megapascal. This is a very important point. These are the process parameters used in the AJM process. The velocity is 150 to 300. It is a very high velocity, 150 to 300 meter per second. In 1 second, this very high velocity. And the diameter of the nozzle from which this mixture is coming is 0.075 to 1 mm. Very small diameter, so that velocity will increase. Okay. Erosive action of the abrasive particle removes the material from the workpiece. This is very common. When the abrasive will hit the workpiece, then it will erode the workpiece, right? So that action of the workpiece will remove the material from the workpiece surface. So what are the various abrasives used? Aluminum oxide, silicon carbide, crushed glass, cubic boron nitride, glass beads, and sodium bicarbonate. These are the popularly used abrasive particles. Okay. Elements of AJM are abrasive feeder. What are the elements of this AJM system? Are abrasive feeder which supply the abrasive, because abrasive has to be provided continuously, right? So because of that, you need to have a feeder which have a huge amount of abrasive to supply. The gas propulsion system for the supply of the gas, the AGM nozzle, the machining chamber and abrasives. Machining chamber is for mixing this gas and the abrasives. Okay. Now we'll see the gas propulsion system generally has supplied gas to propel abrasive particle. Okay. Required quantity of the abrasive particle is supplied by the abrasive feeder and quantity is controlled by inducing vibration to the feeder. It's the same thing. There is a gas propulsion system which provide the gas. There is an abrasive feeder which provide the abrasives and they are mixed and then in the right quantity they are applied to the nozzle to hit to the workpiece. Final. Okay. The machining chamber is closed from outside environment to avoid the pollution. Yeah, this whole process or the machining takes place inside a chamber so that it is protected from the outside environment. Okay. AGM nozzle is usually made up of high water resistant tungsten carbide or sapphire. Okay, this is very common nozzle materials. And the standoff distance. So what is the this is a very important process parameter in any kind of this AGM or other process we'll see. Standoff distance. What is standoff distance? Standoff distance is the distance between the nozzle tip to the workpiece surface. For example, see, if this is the nozzle, right? Sorry. 1 second. See, if this is the nozzle. This is the nozzle. And this is the tip of nozzle. So from here, this flow is coming, abrasive flow is coming, and this is the, for example, a workpiece. The distance between the tip, the nozzle, perpendicular distance to the surface of workpiece, this distance is called the standoff distance. It has to be chosen very correctly so that for effective machining. Generally, for getting the maximum material removal, it is 0.75 to 1 mm. Very close to the workpiece. Okay. Now we'll see a video on abrasive jet machining, how it is done, and it is well explained. Please pause the video.
Abrasive jet machining process, AJM. It is also known as abrasive microblasting, pencil blasting, and microabrasive blasting. It is an abrasive blasting process that uses abrasives propelled by a high-velocity gas to erode material from the workpiece. What is abrasive? An abrasive is a material, often a mineral, that is used to shape or finish a workpiece through rubbing, which leads to part of the workpiece being worn away by friction. The process makes use of an abrasive jet with high velocity to remove material and provide smooth surface finish to hard metallic workpieces. It is similar to water jet machining process. To understand abrasive machining process fully, watch this video till the end. This video will cover the following about abrasive jet machining process. 1. Working principle. 2. Construction. 3. Working. 4. Applications. 5. Advantages and disadvantages. If you are new to ADTW, click on the subscribe button below and turn on the notification. Let's start. Working principle. The fundamental principle of abrasive jet machining involves the use of a high-speed stream of abrasive particles carried by a high-pressure gas or air on the workpiece surface through a nozzle. The metal is removed due to erosion caused by the abrasive particles impacting the work surface at high speed. Construction. The abrasive jet machining setup consists of following things: compressor, air filter, pressure gauge, flow regulator, mixing chamber, hopper, vibrator, nozzle. Working. The air is drawn by the compressor. It pressurizes the gas to a higher pressures. Usually the air is compressed to a pressures between 25 to 130 psi/g. After compressor, there is a filter. The function of the filter is to clean the impurities present in the atmospheric air. After filter, there is a pressure gauge, which shows the exact pressure of the air coming from the compressor. Then the compressed air passes through pressure flow regulator valve. The function of the valve is to regulate the flow rate of abrasive jet. After this, air passes to the mixing chamber. It is used to mix the gas and abrasive particles. Here, in the mixing chamber, the abrasive particles are fed with the help of hopper. The usual size of the abrasive particles is about 0.001 inch or 0.025 millimeters. A vibrator is provided below the mixing chamber. It controls the abrasive powder feed rate in the mixing chamber. Abrasive powder and the compressed air are thoroughly mixed in the mixing chamber. This pressurized mixture of air and abrasive particles is sent to nozzle. The nozzle increases the velocity of the mixture at the expense of its pressure. In other words, as the pressure drops outside the nozzle, all the pressure energy of the jet is converted into velocity. And this high velocity jet hits the workpiece. This jet is used to remove unwanted materials from the workpiece. This is how abrasive jet machining works. Since we understood the working, let us see its applications. The followings are some of the operations that can be.
This is not required. So you have seen how the abrasive jet machining is being done, what are the various apparatus and what are the various parameters are being used. Okay, we'll go to the next process,
Finishing,
which is the water jet machining. So this is similar to the abrasive jet machining, but in case of instead of the abrasives, here water is used for removing the material, because like water is being pushed into the material at a very high speed, so that water removes the material. This is the water jet machining. Rest the process is same only. WN process, also called the hydrodynamic machining, works on the principle of effect of erosion at a high velocity and smaller diameter jet of water on the workpiece. There is no abrasives, there is only water which removes the material. Okay, it uses the high pressure and high velocity water stream against the workpiece for cutting operation. Okay, fine, because you need a high pressure and high velocity in order to make a material removal. And then the fine stream of water can be obtained from the small nozzle with a diameter of a nozzle is given. It's the range of 0.1 to 0.4 mm, because the diameter of the nozzle should be very low, so that less the diameter, more is the velocity. The typical pressure is very high, which is 400 megapascal, and the velocity is produced around 900. See, very high speed, because see, in case of abrasive you can have small velocity, less velocity, because abrasives are itself sharper, so they can hit. But in case of water, you need a very high velocity so that it can lead to the very high impact of water on the workpiece. Okay, high pressure is generated through a combination of oil pump and intensifier. Here, in order to generate high pressure, oil pump and intensifier is used, and intensifier amplifies the oil pressure by 40 times. See, because here you need more than high pressure than abrasive jet machining, because there is no abrasive use. So therefore you require a very high pressure. Because of that, an instrument is used which is called intensifier, which intensify the pressure by about 40 times, very high. Okay, to minimize pulsation in water pressure, an accumulator is used. To minimize pulsation in water pressure, an accumulation is used, and is auto-fidgeted and string-fitted tubes are used to handle this. Okay, fine. A good filtration system is essential to remove all the particles in water during process. A good filtration system is used to remove the small particle, because you need to filter water, right, before reaching to the target surface. So for that, a noise catcher is used. Okay, and what are the various process parameters? These are standoff distance, nozzle diameter, pressure, feed rate, the common process parameter. And the standoff distance, we have already explained the distance between the tool tip and the workpiece surface. It should be 1 to 3 mm for the proper machining. Okay. This is the similar to the abrasive jet, only here water is used, so high velocity and high pressure is required. And additional two instruments are used, which is intensifier to amplify the pressure, and one is the noise catcher to catch the filter for this unwanted small particles. We'll see a video now for the water jet machining, how it is done.
Working of water jet machine. So the major components are reservoir, pump, intensifier, accumulator, control valve, flow regulator, nozzle. So first we see reservoir. Reservoir is used for storing water that is to be used in the machining process. Next is the pump. It pumps the water from reservoir. Next is the intensifier. It is connected to pump. It pressurizes the water acquired from the pump to desired level. Next is the accumulator. It is used for temporarily storing the pressurized water. It connects to flow regulator through a control valve. Next is the control valve. It controls the direction and pressure of pressurized water that is to be supplied to nozzle. Next is the flow regulator. It is used to regulate the flow of water nozzle. It renders the pressurized water as water jet at high velocity. It has orifice diameter varies from 0.08 mm to 0.5 mm, and exit velocity of water jet from nozzle varies up to 920 meter per second. Now we see the working of water jet machining process. So water from reservoir is pumped to intensifier using a hydraulic pump. The intensifier increases pressure of water to required level. Usually water is pressurized to 200 to 400 megapascal. Pressurized water is then sent to accumulator. The accumulator temporarily stores the pressurized water. Pressurized water then enters the nozzle by passing through the control valve and flow regulator. Control valve controls the direction of water and limits the pressure of water under permissible limits. Flow regulator regulates and controls the flow rate of water. Pressurized water finally enters the nozzle. Here it expands with tremendous increase in its kinetic energy. High velocity water jet produced by the nozzle. When these water jets strike the workpiece, stresses are induced. These stresses are used to remove the material from the workpiece.
So we have seen how this water jet machining is being used. Okay. Now we'll see the other processes. Fine. 1 second. Just a second. Okay, we'll see now process which is abrasive water jet machining. Now what is happening, it is a mixture of abrasive jet machining and water jet machining. In with the water, now you are mixing abrasives. Now both are coming. The water is also coming and abrasive is also coming. Here in earlier in abrasive air was coming. Second only water was coming. But now with water this abrasive is coming. So this is very useful process because the impact is very heavy. Okay, the process is same but with water and abrasives are used. So when there is a need of cutting very hard, for cutting very hard and thick material, because both have a high impact. Abrasive is also having high impact, the water is also having an impact, so it can cut a very hard material. So there is a need of cutting very hard and thick metallic parts. Then this AWJM, which is abrasive water jet machining, is used. Is very appropriate as compared to water jet. Okay. In abrasive water jet machining process, the abrasive particles are homogeneously mixed with the water stream. Okay. That impinges on the workpiece surface with a very high kinetic energies. It is that a very high pressure energy is converted into the very high kinetic energy. And then what happened? Water and abrasive streams come from two different reed pipes. See, in one pipe water is there, in this pipe one water is there, and here abrasive is coming. Okay, they come and they mix here. They mix here. This is a mixing chamber. They mix here. Okay. And these two streams mix in the mixing chamber before passing through the nozzle. Okay. Abrasive used in this process are very important: aluminum oxide, silicon dioxide, and garnet. And their size is around 160 to 120. For shallow cutting, not that deep cutting, fine particles and high depth of cut coarse particles are used. Okay. Nozzle orifice diameter is around 0.25 to 0.65 mm and is larger than the WJM process, so that high flow rate and energy at the jet can be achieved. Okay. And water pressure is almost same as W jet machining. And four important subsystems. One is the pumping unit, which provides the pressure. One is abrasive water net nozzle, okay, which provides the abrasive feeding system, which continuously provide the abrasives, and the catcher, which is the noise catcher and everything. And the important factors affecting process are water pressure, nozzle diameter, the size and concentration of abrasive, feed rate, standoff distance, very important parameter, workpiece material, mixing tube, angle of cutting, at what angle this stream is provided, the speed and number of passes. So these are the very common process parameter which are very important. So you have seen what is abrasive water jet machining. Now the video is the same for that, so I am not showed the video now. We'll move to the next process now. The next process is the abrasive flow machining process. So basically, this abrasive flow machining process is not used for, like, very high cutting or very providing very high MRR. It is basically a it's kind of a grinding process, for the finishing process. It is used for the polishing and deburring workpiece with the use of abrasive particle mixed in a viscoelastic polymer medium. There is some a medium in which abrasive is mixed. It is generally used for the finishing process, polishing process, for a very small removal of material, very less removal of material. Okay, so what happened here? The polymeric medium consists of the silly putty, it's a material, and generally silicon carbide particles which are used as abrasives. Very important point. And the mixture of this abrasive and polymer is called medium, and which flows into the work under a pressure of 0.7 to 20 megapascal. Okay, and it is suitable for finishing very complicated shapes on the it is used for polishing both internal and external surfaces. And process variables are the pressure, number of cycles, the stiffness of the medium, workpiece fixture configuration, abrasive size, concentration. This is basically only a use of abrasive on a medium, so that it can be used for a polishing or a finishing process. This is called abrasive flow machining, AFM. Now there is another process called magnetic abrasive finishing, which is MAF. So what happened in magnetic abrasive process? This is also a finishing process. See, in name only finishing is there. It is also a finishing process, but uses it is used as a magnetic particle for doing so. What happened in this process? Finishing process forces are controlled by externally applied magnetic field. There are externally applied magnetic field in which this abrasives are put on the workpiece is controlled by use of that. There is a rotating magnetic pole which creates a magnetic field which control that is moved to the workpiece surface. Okay, this type of finishing process uses a brush which comprises of ferromagnetic particle, okay, abrasive particle, and a binder that get formed due to the magnetic field. Okay, this brush contacts and act upon the surface irregularities of the workpiece. Fine. This magnetic flux density is produced, and this magnetic flux pole is produced, and when we increase this magnetic flux density, surface spin is improved and the rate of material also increases. So we can adjust the magnetic intensity by using this magnetic field, and as per the requirement the MRR can be changed. And the material of the workpiece can be anything. It can be magnetic, non-magnetic, that is not a problem. And the tool has a vibration motion, which is controlled by this magnetic poles. And this surface finish can be improved by increasing the density, increase machining time, higher workpiece speed, and smaller working gap. This is the basic magnetic field, use of magnetic field for the machining process or for the finishing process. Okay. Now we have seen the non-conventional process using the mechanical non-conventional process, in which there was not a contact, but there was a removal of the material using the mechanical process. Now we will see. One second. How the process causing material removal due to melting and vaporization. How this process causing material removal due to the melting and vaporization. So okay. So this basically includes the thermal processes. Okay. Now the very important process, which is called the electrical discharge machining process, EDM. It is a very important process in which the material is removed from the melting and evaporation. See, basically what is happening, I'll explain you in brief, then we'll see the points. So what happened? See, we have this, actually workpiece is connected to cathode, anode which is positive, and a tool is the cathode which is negative, right? So for example, this is one positive, one is negative. So I'll draw it properly. Wait. One is positive, one is negative, right? And in between there is dielectric medium, which can be kerosene, anything, which is dielectric medium. Okay, which can be kerosene or anything. This is connected to a power supply. Okay. Okay. So see, near this positive, which is the anode, and negative, which is the cathode. Cathode is the tool and anode is the workpiece. Okay, what happens? Here is negative charges. Here is negative charges, fine. Here are positive charges close to it. So these are attracted to each other because opposite attract. This get attracted to each other. And what happens? This negative charges coming this side and this positive charge coming this side. Okay. Now what happens? After some times, near to this positive, here comes all the negative charges because of the attraction. And near to this negative, here come all positive charges because of the attraction. So this have a attraction now and this have a attraction now. Fine. It is connected to a voltage supply. Suddenly what happened? This voltage supply, we off it. Okay. When we suddenly off it, what happened? When we suddenly off it, then this plus, for example, we suddenly off it. So here it is like this. It is like this. Here came all the negative charges because of the attraction, and here came all the positive charges. This plus sign and this negative sign, when we off this voltage current, this go and this go. So here is no charge now. Here also no charge. So this particle has no attraction here. This also have no attraction here. So they become very highly volatile. Because of the attractive force they are there. Na? If the attractive force suddenly becomes zero, they become very, for example, you are like holding someone, right? From a quiet time, you are holding someone. Suddenly that person removes his or her hand. You will fall, na? You will become highly volatile. So it becomes highly volatile. And because of that, it lead to melting and evaporation or fusion or blasting. Because of that, it leads to melting and blasting of these electrons, which lead to the machining MRR. This is the basic concept of the EDM process. Now we will see spark is you can see spark is happening and everything is done. So I'll remove this. This is a very important concept which you should know. Rest are the theories and the process parameters you'll understand now. So basically what I have taught, one side we have the cathode, which is a workpiece, which is positive charge. One side we have the anode. One side we have the cathode, which is a tool, which is a negative charge. Because of the supply of voltage in front of the positive charge, the negative get attracted. In front of the negative charge, the positive get attracted, and there have a huge bond between them. But when we suddenly cut off the voltage or current, then the positive and negative charge gone, but the coming particles become very volatile and they lead to the melting and the blasting of the dielectric medium, leading to the spark, which lead to the removal of the material MRR. Okay, this is the basic concept of the EDM. Now you can see in traditional EDM, different shapes are formed by using a electron having negative replica. This is a very different thing. Power supply of 80 to 100 volt is applied, and because of that, electrical field is generated because of the movement of the electrons between the tool and workpiece. An electron move towards the anode. I have already explained the electron move towards the anode because anode is a positive charge, and the ions move towards the tool, towards the cathode, which is a negative charge. And because dielectric fluid here, kerosene is used or deionized water is used to create the path for passage, which I have explained. At the location of minimum gap between the workpiece and the tool, discharge occur and material get vaporized, which is flushed away by the flowing dielectric medium. Okay, the important process parameters are current, voltage, current frequency, the gap, the cycle, everything. And a common tool material is copper, graphite, brass, tungsten. This is basically the concept. Okay, so I'm moving to the next slide and I want to show you a video how a EDM works.
Working of EDM. Let us see the electrical discharge machine process. Tool, workpiece, dielectric fluid. In EDM, the workpiece and tool are submerged in a dielectric fluid and a spark gap of 0.025 to 0.075 millimeter is maintained between the tool and workpiece. By power supply, voltage across the spark gap becomes sufficiently large and causes the dielectric fluid to ionize and breaks down to produce electric sparks between tool and workpiece. This spark melts the work surface and vaporizes the materials. This process is repeated till the required shape is obtained.
So you have seen how this EDM process work. This is basically what we have explained. Now we'll go to the next process, which is a wire EDM. Basically, wire EDM is the EDM process only. Only a coil of wire is used to cut the material. Okay, this workpiece same acts as an anode positive, and this instead of a tool, this wire is a strip of wire is used which acts as a cathode, the negative charge, and it helps, it removes the conducting. But the material should be conducting for this EDM process. For both EDM and wire medium, the material should be conducting, because if there will be no conducting, then there will be no flow of charges, right? Okay. So in this process, a wire of small diameter is used to cut narrow curve in the workpiece. Cutting path is achieved by feeding the wire to workpiece like a band. So you can see in this direction it is cutting. During cutting operation, wire is advanced between the supply pool and the take up a pool to get a fresh electrode for better accuracy and consume. Oh, that is the basic thing. Wire EDM system consists of power supply, dielectric system, wire positioning system, and a drive system. For positioning system, 2-axis stable system. Basically, the same is there, only instead of a tool, a bunch of wire, a wire feeder you have to provide to cut the material. This is the same. Now we have electron beam machining. Electron beam machining. So now what is happening? You are bombarding electrons into the workpiece for the desired machining process. Okay. So you need to generate electrons, and then you need to use different lenses for the so that you can scatter the electron and then diverge it on a workpiece. Okay, this entire process takes place on a vacuum, because if there is no vacuum, because of the external environment, electrons can get deflected. To avoid that deflection, this entire process is used in vacuum. Right, so we have high voltage cable which produces the electrons. Then we have anode, the magnetic lens for the deflection of the electrons and focusing on the workpiece. Because of that, high energy is focused on the workpiece, and because of evaporation happens, and we get the desired machining. Okay, a stream of high velocity electron is focused on the electron workpiece to remove the material by melting and vaporization. Fine. EBM process need a vacuum chamber in order to avoid collision of electron with the gas molecule, that I have already explained. Various applications used in drilling of holes of high aspect ratio 0.0. For a very fine, machining drilling, it is used for this EBM is used. But it is very, very costly process because it required vacuum, very high setup is required. So it is a very costly process. Okay. We'll see a small video how EBM is done.
Electron beam machining. Electron beam machining, or EBM, is a non-conventional machining process used for machining of very hard and brittle materials, which otherwise cannot be machined by conventional machining processes. In electron beam machining process, the kinetic energy of the electron is converted into heat energy by impinging the fast-moving electron on the workpiece surface, This heat energy evaporates the workpiece surface, similar to the laser beam machining process, where a laser is used in place of electron beam. If you are interested in knowing how laser beam machining is carried out, I have provided the link in the description below. Click on the I button to watch it. And if you are new to ADTW, click on the subscribe button below. This video will cover the following about the EDM process. 1. Working principle. 2. Construction. 3. Working. 4. Application. 5. Advantages and disadvantages. Working principle. This machining process works on the basic principle of conversion of kinetic energy of electrons into heat energy. When a high-speed electron impinges on a workpiece, its kinetic energy is converted into heat energy. This heat energy is used to vaporize material at the workpiece interface. This is the basic principle of EBM machining. This process is carried out in the vacuum, otherwise the electrons will collide with the particles in the air and lose its energy. Construction. Construction of electron beam equipment is built similar to electron beam welding machines. Power supply. Electron beam machines utilize voltage in the range of 50 to 200 kV to accelerate the electron to 50% to 80% of the speed of light, which is about 200,000 km per second. Electron gun. It is a cathode ray tube which generates the electrons, accelerates them at a very high speed, and focuses on the required spot on the workpiece. Cathode filament is made up of tungsten, which is heated at about 2500 degrees Celsius, which accelerate the electron emission by thermionic reaction. Anode. Anode is connected to the positive bias. The electrons are pulled towards the anode at very high speed, and, therefore, electrons produced by the cathode filament are not diverged from its path. Magnetic lenses. The emitted electrons are both divergent and convergent. The magnetic lens reduces the divergence of the beam and allows only convergent beam to pass to the next stage. Thus, a highly focused beam of electrons is obtained. Deflecting coil. The deflecting coil does not allow the beam to deflect, thus forming a high-intense beam. Workpiece holding device. The workpiece is held rigidly on the workpiece holding device, which can move in all three directions, that is, in the X, Y, and Z axis. Working. When a high voltage supply is applied to the cathode filament, it generates the electrons. These electrons move toward the anode at very high velocity. After passing through the anode, the beam of electron is made to pass through magnetic lenses, where diverging and low energy electrons are absorbed, and only converging beam of electron is made to pass through it, thus forming high quality electron beam. Then this beam passes through the electromagnetic lens and deflecting coil, which focuses the high-energy electron beam onto the required spot of the workpiece surface. The high-intense electron beam impinges on the workpiece, where kinetic energy of electrons convert into thermal energy. And the workpiece material is removed by this intense heat, thereby melting and vaporizing it. And this whole process is carried out in the vacuum chamber. Application of EBM. 1.
This is not required. So you have seen how this, this is used for how it has been used. Electrons are used in a vacuum chamber to provide a machining. Similarly, we have a laser beam machining in which the laser is, instead of the electrons, laser is used for removing the material. So what laser is a coherent beam of light which is monochromatic in nature, which is very definition of laser. A lens which is used to focus the laser beam in a very small diameter with a much density. A lens is used here, so you can see here. A lens is used which focus this laser so that it can converge on the workpiece and make a required machining. The material is removed in the process by using the light energy of the beam, and which has a potential to remove the material by melting, and we can see that here also the machine is removed used by melting and vaporization of the material by converting that laser energy into the heat energy. Three important elements of laser devices are lasing medium, in which medium this laser is traveling, the pumping energy source required to uphold the motion of at higher energy level, because this laser are produced when there is an energy shift from one level to another. This because of that. An optical feedback system. Okay, fine. And mirrors are used for the reflecting mirrors. Feedback mechanism are used for providing the feedbacks, and it is used for the materials which are having high strength and hardness like ceramics, glass and glass epoxy, plastic, rubber, wood, which is used for that process. Basically here laser is used for providing the machining by using different process, mainly used for the high strength materials like this rubber, plastic, ceramics, etc. This is all about the laser beam machining. We'll see a video for the laser beam machining, how it is done. You can see laser is coming and it is hitting the workpiece. You have seen how with the use of laser cutting this machining has been done. Okay, now one is the plasma arc cutting. This plasma arc cutting is having a highest MRR in compared to all the conventional machining. It is having non-conventional machining very high. A plasma is generated and that is produced on the workpiece, which hits the workpiece with a very high temperature and very high energy and lead to the highly removal of the workpiece. The stream of plasma temperature, which is around 10,000 to 14,000 degrees Celsius, it is very high. Because of that, it uses a power supply and it can transfer. Basically, it has two types of. One is this transfer can be done. The non-transfer type DC power supply or transfer type. It is a very important point. The non-transfer type has lower efficiency with 60 to 85% than a transfer type arc. 80 to 90. It is a type of the plasma arc welding in which non-transfer type having lower efficiency, which is 60 to 85% than a transfer type, which is 80 to 95%. Okay, what are the elements of this PAC, plasma arc cutting? The power supply, gas supply, cooling water system, control console and plasma torch. This is there. And electron materials are generally zirconium, hafnium, these are used. Okay, basically what happens here now, for example gas is there. So gas, when moving into this nozzle, gas dissociates. Okay, for example O2 dissociate into O plus, something, O minus, and then because of that again it try to combine, because it becomes unstable, and because of that this melting and evaporation happens, melting and blasting, and this lead to the MRR because of the plasma gas. Okay, now we'll see ECM. ECM is also very important process. ECM is we have seen this Faraday's laws where one anode is there, see like this, one anode is there, one cathode is there, it connected to a power supply, and here some medium, this electrolyte is there. So there is a flow of electrons from here to here, and this flow of electrons through electrolyte, this one is workpiece, this positive is the anode, which is workpiece, and the negative is the cathode, which is tool. So this flow of materials, because of this there is attraction between charges, and because of there the electrons go into the workpiece materials, and because of ions go into this here, and the removal of this workpiece take place. basic Faraday's law of electrolysis what we know. In this process what happens? A material is removed from electrically conductive material with the help of an anodic dissolution, and shape of the workpiece is same that of the tool for the uniformity, and it is governed by the Faraday law of electrolysis. Okay, different element of ECM are power supply, what power supply you are using, the tool feed system, electrolyte supply system, work systems. Rectifier, one important is rectifier is used to transform high voltage power supply into a low, for a conversion basically rectifier is used. And tool material should have high machinability, conductivity and corrosion resistance, because you are using in the electrolyte, so there is a high chances of corrosion. And both should be electrical conductivity for the flow of electrons. Workpiece should be electrical conductivity, but work holder should be insulator with good thermal stability and low moisture absorption, because if work holder is not insulator, how will hold the workpiece, right? So basically this is happening. You can see this hydrogen generated at the cathode side, and this M plus is generated on the metal oxides are there, and these are the hydroxide. There are transfer of electron, and because of that it comes and corrode this workpiece and erode this workpiece, and the material removal takes place. This is about the ECM process. We'll see a video of the ECM process.
Electrochemical machining, or ECM, is a way of machining a part without actually having any contact between the tool and the workpiece. The workpiece is charged positively, as you can see, and the tool is charged negatively. And between the two pieces there is a tiny gap where they don't actually touch, but there is a electrolyte fluid between the two that slowly removes atoms. And as the tool is slowly moved down towards the workpiece, more and more atoms are removed until the workpiece conforms to the same shape as the tool. This is convenient because there is no actual contact, so there's no tool wear and no friction, which causes heat. This can be used for a variety of parts in many complicated shapes, such as this cylinder that has been machined with a sphere, and this can also be used for tiny parts.
You have seen how ECM process works. So basically this is all about the ECM process, and we have other process called the chemical machining process. So basically what happens in this the material removal is using a chemical reactant, like material removal use place using a chemical reactant. Okay, so what happens here? See, this is the workpiece. Okay, and this is area to be machined. This is the workpiece which is covered with some mask, okay, maskant. And this is the etchant, which is a chemical reagent or chemical reactant, which is called etchant, which is there, and a heating coil is used, and a stirrer is used to stir the etchant. Because of that, the etchant will rotate and will go into the workpiece, and their machining will happen. This is basically the concept of the chemical machining. Okay, the material is removed by using chemical etchant. There are several variants of process: chemical blanking, chemical milling, photochemical machining, and chemical engraving. So what are the various steps used in mechanical chemical machining, sir? These steps need to be followed. First is cleaning. Before chemical machining any workpiece, the surface of the workpiece need to be cleaned of sand and grease for the effective machining. Second is the masking. Then the protective coating is applied on the work surface. It should be applied to the surface that are not going to be etched. You have understood? For the surface which is going to be etched, you don't require masking, right? Because you want to be machined that. But for the surface you don't want to etch, use a mask so that it can be protected. Then etching is done. The step involves the removal of the material. Part is immersed inside the etchant bath. You can see the etchant bath, and the etchant attacks the unmasked surface because the mask is protected, and etchant chemically react with the material to remove it. Okay, after desired amount of material is removed, workpiece is withdrawn from the etchant bath. Okay, fine. Fourth is demasking. That in this step the mask is removed from the workpiece and the required machining has been done. This is all about the chemical process. Now we have completed each and every processes. So if you have any doubt, please ask me so that we can go forward and solve the question. So here basically we have seen various processes, non-conventional process, like in mechanical we have seen ultrasonic, and other water jet, abrasive jet, AFM, abrasive water jet, है ना, the magnetic use of magnetic processes. Then we have seen EDM, ECS, the plasma arc process, then the chemical machining. These are the various processes which use either the mechanical process or the thermal process for removing the material without being in contact with the workpiece in the tool. So this non-conventional process is very useful. Plasma arc having the highest MRR among all, and different mechanisms are used for providing different processes. So please go through once. I'll wait for 5 minutes, then we'll start for the practice questions. Okay. Okay, now let's start the practice questions. So my first question is, conversion efficiency of the electrical to mechanical energies in ultrasonic machining is approximately. So this we have seen very clearly in ultrasonic machining. There is a conversion from the electrical energy to the mechanical energy. Okay, a transducer is there for providing the required frequency, and a tool is moved, reciprocating motion lead to that, and the conversion efficiency is 95%. Sorry, so the answer is D. Okay, all of you got this? Please, this is a very theory. This is a very theory part. So you need to remember this. Okay, you need to go through this. You have to remember this. Okay, so we are going to the next question, which is correct statement for abrasive jet machining. So we know about abrasive jet machining. See, one is the standoff distance is maintained at 2.5 to 5 mm for getting maximum material removal. Okay, it is used for the machining hard and bitter materials. Okay, and the fluid used in AGM can be a gas as well as water along with abrasive particles. And the AGM uses dry air nitro as a for the fluid. See, first of all, in AJM we know that the standard distance is 0.75 to 1 mm for getting maximum material removal for maximum MRR. So first point is wrong. Now we'll see. It is used for machining hard and bitter. Yes, it is used for machining hard and bitter material because abrasives are used. This is right. Third, fluid used in AGM can be used of water. No, because in AGM no water is used. Water is used in what? WJM or AWJM. This is also wrong. Now AGM uses dry. Yeah, it is right. So answer is B and D. Okay. Here answer is D. Here B and D. Okay. Okay. Have you got? See, you need to remember this because see this question can be solved easily. C. But you need to remember the distance, standoff, this values you need to remember. Otherwise, you'll do it wrong in exams. Okay. Now, third question: which of the following are the elements of EBM machine? So we have just seen what are the elements. Yes, magnetic lens is there for that. See, dielectric fluid is not. It is used in EDM, not EBM. It is not there. Magnetic deflecting coil is also there. High voltage cable also there. Answer is A, C and D. We have just seen that what are the various instruments used in the EDM. Okay, this is very simple. Very simple. Next question is, Masking is the process. We just seen masking is done in chemical process. See, the answer is C. Answer is C. It is very easy. It is a very easy question. Next question is, find the correct statement about EDM process. Tool is cathode and the workpiece is anode. It is right because we have tool and workpiece. The workpiece is positive, which is anode. Tool is negative, which is cathode. So this is right. Tool is anode. This is wrong. Kerosene can be used as dilator. It is very right. Material removal takes by vaporization. It is also right because melting and vaporization takes place. So answer is A, C and D. This is based on your revision and your remembrance, how you are remembering things. Rest, just read things so you'll remember. Next thing, tool material used in EDM. What are the various tool material used in EDM? Please say. Silicon carbide is used. No. We have seen copper is used, brass is used, and graphite is used. Silicon carbide is not used. And why it is not used? Because in electric discharge machining, what happens? Na? The electrode is responsible for transport of the electric current to the workpiece. Therefore, any material which is used as electrode is required to conduct electricity. Okay, so copper and graphite and brass are the good conductor of electricity, but here silicon carbide is not that. Therefore, it is not used. Okay, fine. 7. Intensifier and catcher. We have seen intensifier intensify the pressure around 40 times, 50 times, and catcher that removes the noises. It is used in this process. Water jet and abrasive water jets. We have seen already. Where the water is involved, it is used there. The water jet and abrasive water jet. Answer is B and C. Okay. Here answer is B, C and D. Now, 8th question. Which of the following is the part of electrochemical machining? So, electrochemical machining, what is the part? Electrolyte. Etchant is for the chemical, dielectric, it is for the chemical process. It is for the ECM, electrochemical. It is for the EDM, electro discharge machining. And vacuum chamber is EBM, electron beam machining. Right? So, answer is B, electrolyte. Very simple. See, in every process, you need to remember basic things. I am telling you. What is the process parameters? In which everything, the size, the velocity, the pressure, and whatever things. One is the standoff distance, right? And one is the materials, which all materials are used, tool materials, nozzle materials, and third is the mechanism, what mechanism they are using, like melting and warping, and what all other, and fourth is the materials, what all materials are used. You have seen. Okay, this you need to remember. Okay, next question is 9. State true or false. In plasma R cutting, non-transfer type has lower efficiency. Yes, we know that in non-transfer type the efficiency is in non-transfer efficiency is 60 to around 85%, and in transfer type it is around 80 to 95%. So it is less. So it is, answer is true. Answer is A. Here answer is B. Okay. Now the last question is, which of the following process is best suited for the drilling holes of ITNA? So we know for drilling holes for ITNA and 10 mm length, the ductile material. So see, it is a ductile material. So the answer is, see, ultrasonic is not used for this. Electron EDM is not used. Chemical is, what is left? LBM. So laser beam machining is used for this because it is providing a very narrow beam so that it can use for drilling. A. Basically, it is LBM is used for drilling, slotting, scribing, and marking operations. Also in 3D micro machining. and it is used for drill holes from 0.25 to 0.50 mm dia. Okay, so the answer is A. So here we have covered every question, so we are done for this. If you have any doubt, please tell me. This is basically a theory portion, so not much any numericals are there. So theory is there. You need to, as I have discussed, you need to learn about what is the process, what is the mechanism, and what apparatus are used, what materials are used, what are the process parameters, what is the mechanism. Everything you need to just write. You need to know. You don't have to remember each and everything, but basic about the process parameters and mechanism and material you need to know. This is all about this process, and this is also our last class for this session. I hope you enjoyed this session, and you had a I also have a great time in this session. And today our class is not that long because it is a very small class, very less theory classes is there. So if you have any doubt, please tell me. Also, I have this YouTube channel called Abhishek's NPTEL tutorial. One second. Abhishek NPTEL tutorial, where you can watch every video which I have taught here for this NPTEL course. And if then also you have any doubt, then this is my number 7049 881319. This is my number. You can WhatsApp me preferably, and you can also call me, but try to WhatsApp me, and you can get this my number from and you have any doubt, you can ask me, you can call me, and we will discuss. Okay, so yes, this is for your last assignment 8. Please do the assignment 8 very carefully. It will be basically a theory assignments only, and hope you have done the other 7 assignments very effectively and very simply, as we have discussed most of the questions before only, like the practice questions. So this is our last class for the session, and hope you enjoy the classes. And thank you for attending the classes and being so patient, listening for 2 hours, and still being there. And hope we'll meet for the other NPTEL session. And all the best for your exams. Do well. Okay, I'll be closing the session now. Thank you so much.